For 16 years, Detroit's engineers told the world that a battery must live inside its own sealed box, bolted to the chassis, never fused with it. That belief is dead. Leapmotor's cell-to-chassis architecture just proved every word of it wrong. Two 5-seat SUVs, within 17 millimeters of the same length. One of them starts at $57,990. The other starts at $17,040. The gap is not the brand. The gap is 14.5% more battery space, 20% fewer parts, and 25% more torsional stiffness. All because one of these vehicles deleted the battery pack enclosure entirely back in April 2022, and the other one launched this June still hasn't. This is not just an engineering story. This is a supply chain story, a job story, a Rivian story. For over a decade, American automotive engineering held one assumption. As gospel, a battery pack is a component, not a structure. It arrived from the GM Volt and the Nissan Leaf around 2010, hardened by early thermal runaway incidents that made enclosure equal safety, the industry's working religion. Bolt the pack underneath seal, it isolate it from the chassis. And if a cell ever failed, the damage would stay contained inside its own box, never touching the frame the passengers depend on. That caution earned its place. It prevented a generation of early EV fires from becoming structural failures, and it let engineers swap service and recall battery packs without touching the body of the car. Detroit and Tesla both built a decade of consumer trust on that discipline, and that trust was not undeserved. But the assumption outlived its own justification. As cell chemistry, sensor density, and crash modeling matured, the pack must stay a separate box, quietly shifted from an engineering conclusion to an unexamined habit, one nobody at Rivian, GM, or Tesla ever seriously retested at the architecture level. Even Rivian's brand new R2, launched this June as a clean sheet platform, still carries 3 discrete battery modules sealed inside their own housing, sold to the public as innovation. But while Rivian was celebrating its new pack, a company the Western press had spent years dismissing as a low-cost also-ran, had already deleted the pack itself 4 years earlier. Here is the physics problem nobody in Detroit ever solved. A boxed battery pack needs its own structural skeleton to survive torsion and crash loads independently, which means building a second frame inside the car, one that duplicates work. The chassis is already doing. Rivian's R2 handles this the traditional way, a sealed pack bolted beneath the floor, its top plate reinforced separately, just to double as a secondary floor panel. It works, but it is redundant steel, doing a job the chassis should be doing alone. Leapmotor's cell-to-chassis architecture deletes the redundancy entirely. The cell's own casing is coupled directly to the underbody rails. The battery does not sit inside the chassis. It becomes the chassis. The measured result, 25% more torsional stiffness than a conventional bolt-on pack architecture. Take that difference to a Colorado mountain grade with a loaded trailer behind you. Chassis twist under towing load is what determines whether your steering stays precise for the next 100,000 miles, or whether the frame starts fatiguing at the welds 5 years early. Every discrete module needs its own tray, its own casing, its own mounting brackets, and every one of those parts is redundant mass that never touches the road, never adds range, never carries a passenger. Rivian's R2 carries this cost proudly. 3 separate battery modules, 768 cylindrical 4,695 cells. Total each module housed and mounted independently inside the larger pack. Leapmotor's CTC removes an entire structural layer by design. No module trays, no separate mounting hardware layer, just cells coupled straight to the chassis. The result, 20% fewer parts and 15 kilograms shed, with zero compromise to the safety architecture that nearly 30 separate crash and thermal propagation tests were built to validate. Run that math on a Texas highway commute. Every kilogram removed from a vehicle that never touches active cell chemistry is range or payload you get back for free. not from a better battery, but from an architecture that stopped carrying dead weight. Every wall, every module housing every air gap inside a battery pack is space stolen directly from the cells that could otherwise be sitting there generating range. Call it the space tax. And Rivian's R2, with its 3-module structural pack, pays it in full internal housing walls and module boundaries that occupy volume no cell will ever use. Leapmotor's CTC architecture, by coupling cells directly to the underbody, instead of nesting them inside module casings, reclaims that stolen volume. The measured gain 14.5%, more usable battery layout space inside the same footprint. Not a new chemistry, not a denser cell, just an architecture that stopped taxing itself. In a Michigan winter, every additional percent of usable pack volume is buffer more capacity to draw from before range anxiety sets in on a sub-zero highway drive. Charging speed is not just a chemistry problem. It is an architecture problem bound by how much current a pack's physical structure can move without its own boundary walls and thermal paths becoming the bottleneck. Rivian's R2 charges on a 400-volt architecture, taking 29 minutes to go from 10 to 80%. Leapmotor's CTC platform is rated today for 400 kilowatt charging with an 800-volt compatible roadmap. Already announced the structural simplification that removed the pack. Enclosure also removed one of the thermal choke points that limited how fast current could move through it. Picture a midsummer stop on Interstate 10 outside El Paso. The architecture that finishes charging first is not the one with the bigger battery. It is the one that stopped building walls. Current has to fight through to get there. Give Rivian its due first. The R2 is a genuine engineering achievement for an American startup, 656 horsepower from a dual motor layout, 328 miles of EPA-rated range, a 400-volt structural battery that already beats most legacy automakers on power density, and a starting price of $57,990 that undercuts its own R1 lineup by tens of thousands of dollars. Deliveries began June 9th, 2026, and Rivian built this platform from a clean sheet specifically to strip cost out of the components that have historically bled EV manufacturers dry. The packet, the drive units, the wiring harness. That is not a small feat, and it deserves to be said plainly before anything else. Here is exactly where it gets surpassed. The R2's structural battery is still a pack 3 discrete modules, 768 cylindrical cells sealed inside their own housing, with the top plate doing double duty as a floor panel. That is meaningfully more advanced than a conventional bolt-in battery box, but it is not cell-to-chassis. Leapmotor's C10, a 5-seat SUV within 17 millimeters of the R2's length, deleted the pack enclosure category entirely. Back in April 2022, 4 years before the R2 ever reached a customer's driveway. The stiffness part, count, and space utilization gap between the two architectures is not a rounding error. It is a 4-year head start that Rivian's newest, most cost-optimized platform still has not closed. The market consequence follows the same logic that has played out across every segment this channel has documented. Architecture gaps do not stay architecture gaps. They become price gaps, and price gaps become market share gaps. Rivian priced the R2 to compete on cost. But cost leadership built on a 4-year-old architecture is not cost leadership. It is a temporary discount on a design that its own classmate has already surpassed. The supply chain question here is not about lithium or cobalt. It's about who controls the tooling for structural chassis battery integration. Leapmotor has announced it will share its CTC technology, openly free of licensing fees, which means the architecture gap is not protected by patents. Rivian can simply wait out. It is a standard other manufacturers can adopt faster than Rivian can redesign around it. Tariffs do not fix this. You can tax a finished vehicle crossing a border, but you cannot tax an open architecture standard, and you cannot tariff the 4 years Rivian already lost, building a platform around a design its classmate had abandoned in 2022. The labor exposure lands squarely on Rivian's own Normal, Illinois plant. Every engineering team currently tooled around a 3-module sealed housing pack faces the same choice General Motors faced, with Ultium redesign the platform now, or defend a cost structure that a same-segment competitor has already made obsolete. That is not a hypothetical for next decade. It is a decision facing engineers on that line this year, and it lands on Rivian's investor story directly. The R2 was priced and marketed as proof that Rivian solved its cost problem. If the architecture underneath that story is already 4 years behind the capital betting on Rivian's cost turnaround, is betting on a number not on the engineering that number was supposed to represent. What happens next depends not on tariffs, but on whether American engineering culture can move faster than it has in the last 40 years. The battery pack as a separate boxed object bolted beneath a car is not the future of anything. It is a transitional compromise from an era when nobody trusted a battery enough to let it carry structural load, and that era ended in April 2022, whether Detroit noticed or not. Rivian did not fail here. Rivian built a genuinely better version of something that has already stopped needing to exist. That is a harder problem to fix than a bad engine or a slow charger, because the mistake is not in the execution, it is in the premise. 2 5-seat SUVs 17 millimeters apart, 4 years apart in architecture, $40,000 apart in price. One of them is still carrying a box nobody needs anymore. The question is not whether Rivian's battery is good enough today. The question is whether Rivian or Detroit or Tesla will still be building battery packs when the rest of the industry has stopped needing them at all.